Now in this video we will see the solved problems from definite integrals and how to solve problems using properties of definite integrals. Now, the first one is integral 1 to 2 x into x minus x square dx. How are we going to evaluate this? So what is given we first consider and then take this x inside so that you have x square minus x cube, the whole thing multiplied. This is the integrand and x is the variable of integration with the limits 1 to 2. Now we can integrate this first and then integrate this. So you have integral 1 to 2 x square dx, that is on integration gives you x cube by 3 between the limits 1 and 2. In the same way, the second one, integral 1 to 2 x cube dx, this on integration gives you x power 4 by 4 between the limits 1 and 2. So when we substitute the limits, we get 2 cube, that's 8 by 3, and then minus 1 cube, which is 1 by 3, and here 2 power 4, so that is 16 by 4 minus 1 power 4, so you have this. So when you take LCM, you get 8 minus 1 by 3 here and 16 minus 1 by 4 here. So it is 7 by 3 minus 15 by 4. When we take LCM, this is what we get in the denominator 12, and here 4 sevens are 28 and 3 15s are 45. So you have this on simplification, you get this. Now in the same way here we have the second one to evaluate integral 0 to pi by 2 cos square x by 1 plus sine x dx. So what is given we consider and look at the numerator. We rewrite that as 1 minus sine square x, and that can be rewritten again as this is of the form a square minus b square. So a plus b into a minus b. So when we have this way, we can cancel 1 plus sine x. So we are left with this and this on integration. The first one, when you integrate, you get x. Sine x on integration gives you minus cos x. Already one minus sign is there. So x plus cos x between the limit 0 and pi by 2. When we substitute the upper limit, we get cos pi by 2 plus cos pi by 2 minus lower limit gives this. Cos 90 is 0, so we have just to be just pi by 2 plus 0 minus 0, and this is 1. So answer is pi by 2 minus 1. Now we will see solve problems using properties of definite integrals. So first one is prove that integral 0 to pi by 2 sine x by sine x plus cos x dx is pi by 4. So we mainly make use of the second subdivision of the property 4, which we have seen earlier. Integral 0 to a f of x dx can also be written as integral 0 to a f of a minus x dx. So the given integral is to be considered as, say, some capital I. So I is equal to integral 0 to pi by 2 sine x by sine x plus cos x dx. Now we make use of this property P4, so that we can write this as integral 0 to pi by 2 sine of the same I is considered sine of pi by 2 minus x, and in the same way in the denominator sine of pi by 2 minus x plus cos of pi by 2 minus x. Sine 90 minus theta is cos theta, we know. So on that we have the numerator to be cos x, and here sine 90 minus x again cos x, cos 90 minus x sine x. So we have this. I is taken as this. If we consider this as equation 1, if we consider this as equation 1, and the second one, this is the same I only, but we have made use of P4, so we have this. So we add these two. So this is the technique that is going to be followed in almost all the problems of this type. Even the next 2-3 problems we'll have the same technique only. So I, what is given is taken as I, and then apply P4, that is property 4, and get I. Then adding the 2, you get on the left side 2I. On the left side you have 2I, and here on the right side from this one you have sine x by sine x plus cos x. From here you have cos x by cos x plus sine x. So you have the denominator to be the same. Now the limits, everything is the same. So excepting the numerator, which is sine x plus cos x. So that is when we take LCM. And then so we can cancel these two. So we are left with just 1 between the limits 0 and pi by 2. It is integrated. And integration gives you x between the limits 0 and pi by 2. When we substitute the upper limit pi by 2, lower limit 0. So you have pi by 2. Remember, it is only 2i that gives you pi by 2. But our job is to find what is I. So you have I is equal to pi by 4. This should be done. What you are given, that you are taking as I, and then apply P4. There is a second subdivision. Then you get again I in different form. Then you're adding, and for that you are getting the value to be pi by 2. But what we need is this I. Therefore, I should be pi by 4. So similar to that only, we have this cos x by sin x plus cos x. Same 0 to pi by 2. Same problem. But in the previous one, we had sin x in the numerator, and here we have cos x. That is the only difference. But the method is the same, and of course the answer is also pi by 4. Then next one, integral 0 to pi by 2, 1 by 1 plus tan x. So here you take the given integral as capital I and rewrite that as this. So when you rewrite that, you get like this. So which is same as integral 0 to pi by 2 cos x by cos x plus sin x. So it is cos x by cos x plus sin x, the previous problem, second subdivision. So ultimately you will again arrive at the same I only, but it is given in a different form. But when you simplify, it comes to the second subdivision what we had already discussed. So your I, so even in this case 2i only you get, 2i only you get, and as pi by 2, and therefore I is equal to. So this is how it should be concluded. Therefore I is pi by 4. And in all these P4, the second subdivision, that property is only used. Next is integral 0 to pi by 2 square root of cos x by square root of sin x plus root of cos x. We have to show that this is pi by 4 again. So we apply, take the given integral as I, apply P4, the second subdivision, and then we arrive at this. And the denominator is going to be the same for both i's. So numerator is root of cos x in the first case, in the second case root of sin x. So when we take LCM, this is what we get, and cancelling these two, we are left with just 1 as the integrand. 1 is the integrand, and integration gives you x between the limit 0 and pi by 2, upper limit pi by 2, lower limit 0, so pi by 2. So you have 2i again to be pi by 2. Therefore, pi I is equal to pi by 4. Similar to the previous problems. Now the next one, here also it is the same. Integral 0 to pi by 2 square root of cot x by square root of cot x plus root of tan x. Take the given one as I. Apply P4, the second subdivision, and then this is what we arrive at. Again, here also the denominator is the same, and when we add these two, if we name this as equation 1 and this one as 2, adding these two equations, 2i is equal to integral 0 to pi by 2 square root of cot x by square root of cot x plus root tan x dx plus integral 0 to pi by 2 square root of tan x divided by square root of tan x plus root cot x. The denominator is the same. When we simplify that, we get the numerator to be same as the denominator. So cancelling them, we have just integral 0 to pi by 2, 1 into dx, and integration gives you x between the limit 0 and pi by 2. So upper limit is pi by 2, lower limit is 0. So we get this. So 2i equals pi by 2, and therefore I equals pi by 4. So all these questions can be asked in section A. Now integral 0 to pi by 2 square root of tan x by 1 plus root tan x. similar to the previous one. I mean, you will have the denominator to be the same, and numerator we will have that to be, when we add, to be same as the denominator. So cancelling out, because they are the same, integral 0 to pi by 2, 1 into dx we have. So as before, we will get 2i to be equal to pi by 2, 2i to be equal to pi by 2, from which I we get as pi by 4. So now in the fourth property we had two subdivisions. So far we have been using the second subdivision. Now we'll have an illustration how the first one can be used. You're given, evaluate this integral between 2 and 3, 5 minus x to the power 4. One way of doing this is you have to expand this binomially. You will have 5 terms on integration with respect to x, and then substituting the limits, upper and lower limit. So it will be tedious, so for which we can make use of this. It is not tough, but it is tedious. So we consider integral 2 to 3, 5 minus x to the power 4 dx. We can easily see that this 5 we can write as taking this as a and b, so that you can have a plus b minus x. So your function, this one what you have here, f of a plus b minus x, is nothing but here 2 plus 3 minus x power 4. So according to this, it should be f of x, which means here see f of 2 plus 3 minus x is 2 plus 3 minus x to the power 4. Therefore, f of x will be just x to the power 4. So you have whatever you have here just becomes as just x power 4. Between the limits 2 and 3, we have to integrate that and substitute the limit. So x power 5 by 5, upper limit 3, so 3 power 5 by 5, lower limit 2, so 2 power 5 by 5. On a simplification is what we get. So this is the final answer. Now the next one again, here too we make use of the first subdivision. You are given beta to pi minus beta, integral beta to pi minus beta theta d theta by sine theta is something, pi log cot beta by 2, with beta taking these values. So because of this, they are giving the limit for beta also, it has to lie between these two. And we consider what is on the left side as I, and then we can rewrite this theta as beta plus pi minus beta theta. See, we can cancel these two. See, it is like this. You have f of theta to be theta. So when we consider f of a plus b minus x, so that means here it is f of beta plus pi minus beta minus theta. So that will be what we have here, beta plus pi minus beta theta, and in the denominator also we have f of theta is theta by sine theta. So it will be sine of a plus b minus x. So a plus b means here it is beta plus pi minus beta minus theta. We can cancel these two. So sine pi minus theta is sine theta. So that is what we have here in the denominator. So integral beta to pi minus beta, beta plus pi minus beta theta. So actually speaking, here we could have had beta plus pi minus beta minus theta, which is same as sine theta, sine of this. So in the numerator we can cancel again that beta, so we are left with pi minus theta d theta by sine theta. So I is this, I is also this. So if we name this as 1 and this as 2, adding the 2 we get 2i equals integral beta to pi minus beta. We are adding these two, so this part will go off. So we are left with pi d theta sine theta. Take this pi out. We know that uh, integral dx by sine x is log tan x. You can verify also, that is when you differentiate that you should get this. So it is 1 by tan x. Tan x on integration gives you secant square x. So this you can rewrite as 1 by cos square x into sin x by cos x. We can cancel this. So what you are having here is this is tan x by 2. So this function rule that we have to have, so that gives you half. So you have cos square x by 2 sin x by 2 cos x by 2. Can cancel one this thing. So 2, you will be left with 2 into sin x by 2 cos x by 2, which is 1 by sin x. So the integral of 1 by sin x dx is log tan x by 2. So that is what is written here, and lower limit beta, upper limit pi minus beta. When we substitute the upper limit, we get log of tan pi minus beta by 2 minus lower limit gives you this. Remember, on the left side we have 2i. So this is what we have, and coming to this, tan 90 minus theta is cot theta. Tan 90 minus theta is cot theta. So you have cot beta by 2, and this is minus log tan beta by 2, which we can write as log 1 by tan beta by 2, which is cot beta by 2. So 2 times log cot beta by 2 that we get. Already pi is there. So 2i equals 2 pi log cot beta by 2. And we can cancel 1, 2. So we are left with I is equal to pi log cot beta by 2. Pi log cot beta by 2. Now the next one, find the value of integral 0 to pi x sin x by 1 plus cos square x. So take the given one as x sin x, I as what is given, and find f of pi minus x. So we have to make use of the P4, so we are doing this. So f of pi minus x gives you, wherever you have x, replace it by pi minus x. So sin pi minus x divided by 1 plus this. So cos pi minus x is minus cos x, but here you have square. So you have 1 plus cos square x in the denominator, and in the numerator we know that sin pi minus theta is sin theta. So this is what we get. So I is given by this. I is given by this, and I is also given by this. This is by P4 second subdivision, and adding these two, if we name this as 1 and this as 2, then adding the 2 we have this. So we are having 2i to be pi into integral 0 to pi sin x dx by 1 plus cos square x. Now we will consider, so here by substitution method we are going to evaluate this. See, up to this we have made use of properties of definite integral. So those properties are used up to this. Then from here usual method of integrating that, either substitution method or whatever, depending on the problem given. So we shall take our z as cos x, so the dz will be minus sin x dx. When x is 0, you have cos 0 to be 1, so z equals 1. When x is pi, cos pi, you get it as minus 1, so you have z to be minus 1. So the limits becomes 1 to minus 1. Already sin x dx we have got it as minus dz, so this minus dz by 1 plus z square that you have, and because of minus sign, and here it is 1 to minus 1, so we can change it minus 1 to 1, integral dz by 1 plus again properties of definite integrals we have used. First property, so you have this, and this is even function. When we have even function, we know that minus a to a becomes twice integral, so it becomes twice integral tan inverse of z between the limit 0 and 1. Tan inverse of z between the limits, like this also we can do, so that for the upper limit we have value, that's pi by 4, so 2 into pi by 4, but for the lower limit it is 0, so you get it as pi by 2. So the value for this is pi by 2, but already one pi is there, so we get pi square by 2, but 2i is only pi square by 2, and therefore I is pi square by 4. So we get the value for this to be pi square by 4. Now the next one, evaluate integral 0 to pi by 2 x dx by sin x plus cos x. Take the given integral as I, and when we have f of x as this, like before, f of pi by 2 minus x. Here a is pi by 2, for that only this is calculated. Now sin 90 minus x cos x, cos 90 minus x sin x. So since integral 0 to a, that is we make use of this property P4 second subdivision, we have this step. So I is also equal to integral 0 to pi by 2 minus x dx by this. Now I is this, the first one we have I to be this, and I is also to be this, so we add these two, so this x term will get cancelled, giving and this alone. Now up to this we have made use of properties of definite integral. Then to evaluate this, what we do is, we know that sin x is given by sin 2 theta formula, we know it is 2 tan theta by 1 plus tan square theta. So if we want to have sin theta, means it is 2 tan theta by 2 divided by 1 plus tan square theta by 2. So taking tan theta by 2 as t. Okay, so in this case instead of theta we have x. So taking t as tan x by 2, we see that sin x is 2t by 1 plus t square, and cos theta we know that it is 1 minus tan square theta by 2 divided by 1 plus tan square theta by 2. So it is cos x therefore is 1 minus t square by 1 plus t square. So in this we are going to substitute that. So when we substitute, because the denominator we have in both the cases 1 plus t square, we have this to be, and remember dx, see t is this, t is tan x by 2, so dt will be secant square x by 2 into dx by 2. Therefore dx will be 2 into dx only we need, so 2 dt by 2 dt, this one will go down, so secant square x by 2, but we know that this can be written as 2 dt by 1 plus t square. So you have dx to be 2 into dt 1 plus t square. And this 1 plus t square, it will be there in the denominator, common to both of them. So it will be like this, 1 plus t square and dt by 1 plus t square. So this and this will get cancelled, giving only 2 times dt by 2t plus 1 minus t square. We can cancel this 2 out, so that pi into, integral 0 to 1, the limits. See, when x takes the value 0, t is 0. When x takes the value pi by 2, t will be tan pi by 4, but we know that tan pi by 4 is 1. So that is why you're getting here the lower limit as 0, upper limit as 1, and the integrand to be like this. Now this is rewritten in this way, integral 0 to 1 dt. You're just rewriting this, so t minus 1 completing the squares. So this is what we arrive at, and this can be rewritten in this way, root 2 the whole square, and substitution method that is used here. T minus 1 is taken as z, so that dz will be dt, and when t takes the value, so when t takes the value 0, z is minus 1. When t takes the value 1, it is 0. So that is what we have here. And dz by square root of this 2 is rewritten as root 2 square. So we have this. Now this is of the form integral dx by a square minus x square, which we know that 1 by 2a logarithm of a minus x, a plus x by a minus x. So that formula is used, integration formula that is used. So you have 1 by 2 into, in the place of a we have root 2. So 1 by 2a log of root 2 plus z divided by root 2 minus z, between the limits minus 1 and 0. So 2 root 2 is taken out, then applying the upper limit, we get log of root 2 by root 2 minus log of root 2 minus 1 by root 2 plus 1. But log 1 being 0, we have 0 here, and this is minus of this. So to avoid minus sign, this will go up, this one will go up, and this one will come down. This one will go up and that will come down. So you have log of root 2 plus 1 by log of root 2 minus 1. Already pi by 2 root 2 is there already. If you want to further simplify this, you can do further simplification. Otherwise, we can stop at this stage. If you're asked to show something that this has to be like this, otherwise even we can stop at this stage. Now this problem, we make use of properties of different integrals, but the approach is somewhat different, and it is an important problem also. Show that integral 0 to pi by 2 logarithm of sine x dx is minus pi by 2 log 2, or you can also show it as pi by 2 log half. Both are the same. You consider the given integral as I. That is, integral 0 to pi by 2 log sine x dx is taken as I, and the same I can also be written using P4. You can write like this. Then adding the two, you have logarithm of, the integrand becomes logarithm of sine x plus logarithm of cos x. Log a plus log b is log ab. So you have this step, and we know that this is nothing but sine 2x by 2. So 2i on the left side, that we keep writing. So the right side is integral 0 to pi by 2 logarithm of, this is sine 2x by 2. So this is what we have. Now integral 0 to pi by 2 log a by b is log a minus log b. So we have used that, and this is what we have arrived at. Now we will consider this alone separately and show that this is nothing but I itself. So once that is shown, 2I minus I we will get, and that will be minus pi by 2 log 2, which is rewritten as this, because log 1 is 0, we can rewrite like this. So everything now depends on showing that integral 0 to pi by 2 log sine 2x dx is just I. Once that is shown, then the problem will be over. So we shall consider log sine 2x dx separately. Integral 0 to pi by 2 log sine 2x dx. You put t 2x as t, so that 2 dx will be dt. 2 dx will be dt, or dx will be dt by 2. So that is what we have here. And log sine t, the limits will change now as this. When x takes the value 0, t also takes the value 0. When x takes the value pi by 2, t takes the value x is pi by 2. In that case, t, which is 2x, will take the value 2 into pi by 2, that is pi. So that is what we have here as the upper limit. Now we are going to rewrite this pi. See, we have this pi, that is rewritten as 2 into pi by 2. Right. Now we have integral 0 to 2a, some function. Now we go to property 6. What does it say? When we have this net, that is f of 2a minus x equals f of x. So in this case, our function is f of x is equal to log sine x. Or rather, if you are going to apply it for t, means f of t is log sine t. Now, if you are able to check whether f of, in this case, what is 2a? 2a is 2 into pi by 2, that is pi. So if you are able to show that 2a minus t, f of 2a minus t is also f of t, then we can make use of this. Otherwise, we cannot use this one. If it is you are getting as minus sign with the negative sign, means then you will have the value to be 0. So we will check this. 2a is nothing but pi. So f of pi minus t we will check. What will be that? It will be logarithm of sine pi minus t. But we know that sine pi minus t is sine t itself. So we are getting back. So f of 2a minus t we are getting it as f of t itself. So we can make use of this. So this man will come down. Already you have half here. So this 2 jumps down. So integral 0 to pi by 2 log sine t dt. But this is known already as I. So we have this. So your equation 1 now becomes 2i equal to the first integral alone we consider, and that also we have got it as I. So 2i, take this I to the left side. So I equals minus integral 0 to pi by 2 log 2 dx. But log 2 a constant, so you can take it out. So you have log 2 minus integral 0 to pi by 2 dx. So that is log 2 into, if we substitute the upper limit, we get minus pi by 2. So minus pi by 2 log 2, or you can write this as log 1 being 0, pi by 2 into log 1 minus log 2. So that gives us pi by 2. Log a minus log b is log a by b. So it is an important problem, that integral 0 to pi by 2 log sine x dx is pi by 2 log half. So in the next video, we will consider the properties of a reduction formula, and then how easily that we can evaluate integral 0 to pi by 2 sine x power n dx, whatever may be that n, and similarly cos x power n dx, and sine x power m cos x power n, integral between the limit 0 and pi by 2, how to evaluate that. So in the upcoming videos we will see them.